In this video, we're going to get an introduction to functions. So first we have to go through some definitions. The first thing is a relation. A relation is a set of ordered pairs. So in that ordered pair, it could be anything. It could be, what the state is and how many representatives that state has. It's just a set of inputs and outputs. Okay, it can be anything, and anything can go to anything. There's no restrictions. It's just a set of ordered pairs. Now, a function is a relation in which the input has exactly one output. Okay, meaning if I have an input, it can only go to one output. It can't go to something else as well. It'd be like your boss saying, today you're going to get paid $10 an hour or $2 an hour. Nobody wants to hear that, okay? So a function has to be something that for each input there's only one output. If you work so many hours in a day, you know how much money you're going to make. It's not this or that. There can't be two outputs for your one input of time. Okay, so some examples of real life functions would be, if I'm driving 60 miles per hour, so I'm going at a certain rate, then my distance is going to be determined by how long I drive that rate, or something like that. So that is a function, okay? So for every input, I can only have one output. It has to make sense in that way. So I'm going to go through a bunch of problems, and we're just going to talk about first whether or not the relation, so the set of ordered pairs or table or whatever we're given, is or is not a function. So in this first set, I have some inputs of states. I have some outputs of how many representatives they have. And we want to know whether or not this is a function. So for each input, I can only go to one output. So Arkansas has 4 representatives. Texas has 32. Oklahoma has 5. Oregon has 5. Now we see a repeat here, but that's okay. It's okay to have a repeat in the output as long as that input, so Oklahoma only has 5 representatives. It doesn't have 10 and 5. It only has 5 representatives. So repeat in the output is okay. You can't repeat the inputs. Now if I wrote Oregon here again, Oregon better go to 5. Generally we don't repeat the inputs in that sense where they're identical, but if you see something like that on homework, Oregon can only have 5, or a number or a letter can only go to one value. Now it's okay if it's repeated in the set as long as that input goes to the exact same value. Okay, so in this case, this first example is a function, so yes, it is a function. Now for the rest of these, I'm just going to write yes or no. Let's look at example B. So -3 goes to 7, 1 goes to 7, and 2 goes to 2. So when we have a list of ordered pairs in general, X is the input and Y is the output. So I have the different inputs of -3, 1, and 2. I see no repeats in the X values. It's okay to have repeats in the Y. So yes, this is a function. Okay, looking at the next one, I have the inputs of 1, 2, 0, 0. So wait, I see a repeat in my input. It has to go the exact same value. So 0 goes to 3, but over here 0 goes to -2. So because of these ordered pairs, this is not a function. No, it's not a function. I have one input, the one input of 0, going to 2 different outputs. Now if this said 0, 3, 0, 3, that's okay. It's the exact same point, this exact same values. But because the Y value is different, one input, 2 different outputs, that's not okay. We can also look at these same ordered pairs in a chart form or a table form here. So I have A going to 4, C going to 32, B going to 10, and C goes to 5. So I see a repeat in the input of C's. C goes to 32 and C goes to 5. So no, this is not a function because of this set here. C goes to 2 different outputs. That's not okay. And looking down here at this table, I see the inputs, again I said, are the x values in general, and the outputs are the y values. So I have 1 going to 7, negative 3 going to 7. You might say, hey wait, I see a repeat, but that's in the output. 1 itself only goes to 7, negative 3 only goes to 7, and 5 only goes to 4. So for each one of these distinct inputs, they only go to one output. So yes, this is a function. So repeats in the x's, you have to make sure that they go to the same value, or for each distinct input, they have to only go to one output. Repeats in the output are okay. If I wanted to know if a graph is a function, I use the vertical line test. So a vertical line test means that when I draw a vertical line through the graph at any point in the graph, it can only touch that vertical line at one spot. If it touches it twice, it's not a function, because that means that for that one x value, that one input, I have 2 different y values, 2 different outputs. So looking at this first graph, we already have some vertical lines, going through it based on the graph itself, and I can see that at any point I would only touch that vertical line once. No matter where I draw the graph, it's only going to touch that vertical line once. So yes, this is a function. Here I have a horizontal line. Same thing. No matter where I draw a vertical line, it's only going to touch the graph at one possible point. There's nowhere that it would touch a vertical line twice. Yes, this is a function. Over here I have an ellipse. If I draw a vertical line through the ellipse, wait a second, I see 2 points touching that vertical line. No, this is not a function. So for that one x value, so at this point I was trying to draw it on 2 here, it's not quite there, but going through x equals 2, x would go to positive 2, and x would go to 1, 2, 3, about 4.5. So that one x value has 2 different outputs, not a function. If we keep going, we'll see here, if I draw vertical lines at any point, this looks okay, and over here this area looks okay. The only question I have is right there, right here, crossing or touching the y-axis. So it looks like maybe it touches at 2 points, but really it's not, because this is a curved line. It's getting closer and closer and closer to the y-axis, and here it's curving, 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 curving. It's only going to touch that y-axis right there. So this is a function. Now what about a vertical line? Well, if I draw a vertical line through that vertical line, I'm touching it infinitely many places. This is definitely not a function. What about this little squiggle guy here? Well, same thing. If I draw vertical lines anywhere through this graph, it's only ever going to touch at one point. Yes, this is a function. Now sometimes functions are not specific graphs that are continuous like this. Sometimes it's just a collection of data like those tables. So the tables above, I could plot down here on a graph, and I can still use this vertical line test to determine whether or not this graph is a function. So a function can be a collection of points. Touches it once. If I draw through here, touches it once, touches it once. All of these, there's no repeats. So no matter where I draw that vertical line, it's only touching it at one place. Yes, this is a function. Over here, if I draw a vertical line, so I need to know, is it going to touch it twice? Yes. So right here, if I draw a vertical line, I have 2 points touching that line. No, this is not a function. For that one x input, I had 2 different y values. Not okay. Whoops. Let's see what's going on with my graph here. One last thing, I want to know if these are functions. So a parabola or a quadratic function here, if I draw vertical lines through it at any point, yes, this would be a function. Here, if I draw a vertical line through it, I see 2 points touching that vertical line. No, not a function. Anywhere I draw vertical lines through this is an absolute value equation. Anywhere I draw vertical lines, it's only going to touch it once. Yes, this is a function. And the same thing with this square root. I can draw vertical lines anywhere I want. It's only going to touch it one spot. So yes, square root functions are also functions. I just said that twice. So these are from that parent graph page that I showed you in a previous video. Quadratics or x squared functions will always, I shouldn't say functions, x squared equations will always be functions. Absolute value equations will be functions, and square root equations will be functions.
On these last two, they look kind of unique. They're segmented parts of a graph, but the line test still applies. I checked to see if it would touch anywhere twice. Doesn't look like it would ever touch a vertical line twice, so yes, this is a function. Same thing here, I check using my vertical line test. I don't see anywhere that it would touch twice. Yes, this is a function.